Hello and welcome to my YouTube channel Java Stories, and this is the part 2 of the series. We are trying to solve the José Paumard puzzles of the collectors. We have solved the first 4 questions till here, till this fourth question, and now we will try to solve the remaining 3 questions, and we will see how we could solve this. So if you have not watched my previous video regarding this series, so please watch that first, and the link is in the top right. So let's start. So the question is, gather all the letters used to write the sonnet in the lowercase and find all the least used in a list. Remember to use buffer reader. Okay. So this sonnet is basically a file. So we are going to read the files. We are going to read line by line. Then we will split those into words the way we are doing in the previous question. And then we will convert each word into letters, and then we are going to lowercase those letters, and then we are going to find the least character which is used. Now here in this question we need to find nearly all the least characters. Suppose there is a tie at the topmost position, we need to find all of them. In the previous question we have just find any of them. Here we are going to find all of them. So let's see how we could solve this. Reader.lines. This reader.lines is going to read line by line. Now each line needs to be converted into a stream of words. So of course one-to-many relationship is there. We need to use flatMap, and we could use the same split pattern, split a stream. Now we have stream of words. This stream of words needs to be converted into stream of letters. One word is a combination of letters. So of course this is also a flatMap, one-to-many relationship. We are going to receive a word, and we need to convert this into a stream of letters. So how we could do word.chars? We have known that this returns stream of integers, and each integer basically represents the ASCII value of that letter. So this is a primitive int, we boxed it. So now we are getting a stream of integers, and each integer represents a character in the ASCII. So we need to convert from this integer back to the letter itself. The letter is now going to be a string, a single letter string. So how we could do this? We just need to do a map, and we are going to receive a letter now. Letter in integer, let me just write this as well. Letter in integer. We need to convert this back to the string. See, we have this toString which takes this integer. So we could just write letter integer. If I check this, what it is returning to me, and it's returning a stream of strings, which really I want. Now from here, since I need to also lowercase all these letters, there may be some uppercase, there may be some lowercase, so it's quite easy. I could just take this letter now, and I could say letter dot lowercase. We should have this lowercase, and yeah, we are ready to go. Now we need to group by, because now we want to calculate the frequency map of all these letters. We have done this quite a few times. Collectors.groupingBy. The grouping by needs to be done on the letter itself. So this is simple s.s, or even if a better letter. Now I need to do collectors.counting, and if I now check what's the return type, this is a frequency map, which is great. Now I need to find basically the minimum letter here. Of course I need to open. Okay, one more thing I want to say. If I just check this, so all these letters along with their frequency we have got, but there can be multiple letters with the same frequency. In such scenarios, what we have done, we have to first reverse this map. Like we want this to be long and this to be a list of like letters here. So we have to reverse this map so that we could find all the least used characters. That will be the first position of this map then, if we sort that map in the ascending order. So let me try to open now a map on this, a stream on this. So this is an entry set, this is a stream, and now I have to collect this collectors.groupingBy on bit basis, of course. Now on the get value, we have to reverse the map, and this is quite easy. Collectors dot to list. Now we see we have got the proper what we want. If we want a list of string instead of this map.entry, then what we could do here, we have to provide collectors.mapping, because this also give to give you an entry, and I just want get value only, and then collectors.toList. If I check this now, get sorry. See, now we have got the this long represents the frequency, and this represents all the letters with the same frequency in the key. I think we have got this now. Now I have to find the minimum of it. Again, entry set, again stream, min on the base of key now, comparing by key, and of course this is going to return me an optional. I'm opening the optional, and this is my answer. If I do this and remove these two asserts, these two characters, just give me a just let me do this collect itself, and collect.get value, and use this in this, and use a new local variable, and this is the least used characters. And let me run this. See, the test has passed. So basically, let me also just print out for you least used characters. See, K and B are the least used characters in that sonnet file. Hope you got the gist here. This is giving us so many yellow, and let's see whether we could reduce this to lambda expressions. And this is also can be reduced to lambda, method reference. And this can be, I am not doing that. If check, we will see in for future videos how we could handle all these optionals in the stream pipelines. But as of now, this looks good to me. Let us come to this question now. From the word in the text file, create a nested map where the outer map is a map from the first letter of the word to an inner map. And how this inner map is going to work? This is also mapping from the length of the word to a list of words with that length. So let's see the example. Suppose this is the given words. So the outer map key basically represents the first letter of these each words, and if the letters are common, then you have to group by, like B, like F. We have only two distinct letters, F and B here, so that is why the outer map key is B and F. And the inner one, what's trying to do, Now, how many words are there with F? Foo and foo. So with F, uh, so with it's like I cannot say what's trying to say. It's like there are two words of length 3 here. If suppose there's one more like first here, then I suppose this should be like this, then 4 first, because starting with F, there are two words with length 3 and one word with length 4. In the B part, you will see of length 3 there are two words, and with length 4 there is baz. So this is the way we have to create a map of a map. The outer map key will be the first letter of each word. If they are common, then you have to group by, and then you have to find another map. The key will be the length, and based on the length you have to group by those words. I think this is also quite easy. I request you to read these lines again and try to get the gist from this example. And let me just now do that. Reader.lines, and of course the flat map will come into picture. Split pattern, split as stream. We have got the words we have to collect, and how we have to collect. I'm like collectors.groupingBy. The outer map has to be the first letter of the word. So this is a word and word dot substring 0, 1. So I am grouping based on the first letter of each word. Now how I am going to collect this. I am going to create a second map now. Again I have to do a collectors.groupingBy. Now that word, let me give this a word 1. I have to group by based on the length now. Length, and I have to collect all the words now. Collectors.toList. I think so we are done. So this is the key of the outer map. Inner map, for each word we are grouping by the length itself, because here we have to do by length, and we have to collect all the words. So we are collecting all the words. If I just check this, their answer. Let me just take this into results. If I just uncomment all these lines, let me check whether this is running successfully or not. See, this is getting passed. So we are able to solve this problem as well. Why this is giving us yellow? Let's see this with method reference, and I think so we are done. So always do first lambda expressions and then try to convert into method reference. You will get more and more confidence on the method reference. Now comes the last part. Given a string of integers, compute separate sums of the even and the odd values. This is quite easy. We already have the input string. We have to just collect this. Collectors. We have to do a partition by. How we are going to do a partition by? We are going to collect all the even in the true, because partition by gives you a map and the key is a boolean. So you have to give a condition, a predicate here. So we have given if it is divisible by 2, consider it as an even, and sum it as well. Summarizing int s comma s. That's it. And let me also do the box on it, so that this s percentage by 2 works nicely. Now there is a problem, one more. And if I collect this in my bare answer, Answer.get true is my sum of event like this, and some odds will be in the false. Answer.get false. Hope you got the gist. This partition by I have never explained, but consider this like a grouping by, just like the key will always be true or false. So for the true case, we are summing all the ints, and for the false case, we are summing all the odd event, like odd sums. If I run this, why this giving problem? I really don't know. Insert equals import static. Yes. See, this is also running quite nicely. So we are able to solve all the questions of the José Paumard, and I think these are some nice questions. If you are able to do these kind of a questions, then I really think that some new questions, at least you will know how to proceed. If you are not able to even solve that problem, you will not get stuck in the interview blank face. You are going to do something and try to explain something in the interview, and that's what is really important in the interview. Thanks for watching. Please subscribe to my channel, like this video,